So we just have found out that our data contains 992 zero values, non-zero values, and we have generally a lot of zero values. So it should give us 9008. So this perfectly fits the same example. If you remember, we have modeled the Poisson claims with 9002 claims at the first site in a couple of lectures ago. So generally our function works correctly. It produces the Poisson values. What is the variance of our data? This value. And also let's understand. So summary doesn't give us the full information because it contains, the data contains lots of observations. So let us also recalculate the summary using the subset of our data. Using the subset of data which data more than 0. Okay, so this is the summary of values which are non-zero, and the plot of our data should show us the significant peak, plot density. Yes, it shows us significant peak here. So in general, this is Poisson data. Okay, lambda here was taken as 0.1 and mu was taken 100. For this model, we can calculate the probability that S equals to 0, and this probability is just the exponent of minus lambda. Okay, lambda should be set. It is 0.1. So this exponent gives us 0.9048, and the expected value gives us about 10, and the variance is about 2000. Okay. Okay. Exponent 0.1. So expected value of S. E of S. It should be mu over lambda. So it will be 100 over why mu times lambda. Okay. 0.1 times 100, so it will be 10, and 10 squared. This will be the variance. Again, once again, why variance is 10 over 1? No, something is wrong. Variance of S should be 2000. Variance of S should be 2000. Okay, we'll leave it for next time. variance of S equals to 2000. So our values are more or less likely to these values, and that's alright. And also, what should we calculate? So we will now apply these several principles. First principle we need to apply is EVP principle. EVP. So what are the values for EVP? Use EVP with relative security loadings of 50 and 150%. Okay, 0.5 and 1.5. So P will be mean of data plus 0.5 times mean of data. So P will be 15.2. This is the premium which is calculated using the security loading of 0.5. And if we will use the security loading of 1.5, 150%, the P will be 25. Okay, this is the how we implement this EVP principle. So we have to charge premium, which is about the size, about the value of, about the mean value of our claims, plus some alpha which is more than 0. This is the risk premium. So we just select, the company selects it by itself. The second principle we need to use is the SDP 0.2 and 1645. So SDP. So how to implement? We also will use this mean of data plus 0.2 times standard deviation of our data. Okay, what was the result? So P is 19.14 in my case. And the second option, hold on, and the second option is 1645. And premium, of course, will be lots and lots higher, 84.24. So what principle can we use next? VP with 001 and then QP with 95 percentile. So VP uses the variance to calculate, and P will be mean data plus 001 times variance of our data. So premium will be 30.43. And the last principle is quantile principle. Okay, what will be the quantile? Quantile of 95. Can I calculate quantile of data (0.95). Is it returning anything? So it returns 70. So we will use this temp to extract the quantile. Temp 1. Okay. So quantile 1. Okay. So for quantile principle of 0.95, we will use p equal to mean data plus quantile. So and p here will be 80.25. Okay, let me check the quantile principle once again. So let me also (74). Co-exponent of 0.95 and co-Poisson of lambda this is 45, and if we use the mean data, it will be only 55, right? No, okay, we will stick with this definition here. Alright. The question is, should we add the mean data to the quantile principle or not? Mean plus quantile, it is pretty high. What if we just leave only quantile? So p will be 70. Okay, I'll stick with this variant in the final. Correct. Okay. So these are 4 different principles to calculate the premium depending on the distribution we have. In this case we have the distribution which was the compound distribution. It was contained Poisson distribution, and in order to make it compound we summed up the exponents where x was exponentially distributed with mean, so we summed up the exponents. We then created the data from 10,000 observations, and then we calculated 4 different types of premiums depending on the method of which we use. The easiest one, of course, is the EVP principle. We just need to know the mean of our data. For SDP and VV principle, we need to know standard deviation. For quantile, we need to know the data itself, so just the higher order of quantile.